simplify radicals, you're going to break them into the product of two other numbers. Biggest thing is just making sure that when you split them, break them into things you know the square root of, such as 5 and 10 won't work here. I don't know the square root of 5, I don't know the square root of 10, so we're going to have to break it into something different. We can split 50 into the square root of 25 times the square root of 2. And since I know the square root of 25, it can be brought on the outside, and my final answer is 5 times the square root of 2. To add or subtract radicals, they must be alike, such as right here we have the square root of 5 and the square root of 20. Those won't combine. But once we do simplify this, again, we can split root 20 into the square root of 4 times 5. And since I know the square root of 4, I can remove it outside. So now I have 2 times the square root of 5 plus 6 times the square root of 5, which can be combined. We're only going to combine coefficients. 2 plus 6 is 8, and leave the square root of 5 alone. Anything can be multiplied. To multiply two expressions, simply multiply the pieces that are alike. We're going to combine the like pieces, such as 3 times 4 neither have a radical. We can multiply those, gives us 12. Root 2 times root 3 gives us root 6, and we always look to simplify if at all possible. The same way that anything can be multiplied, anything can also be divided. Now, we must be careful because the term division also includes simplifying fractions. So 6 divided by 9, we always stay with the things that are alike. We're going to do 6 divided by 9 by simply reducing it. Divide the top by 3, divide the bottom by 3. In the same way that we can reduce numbers without radicals, we can also reduce numbers with radicals. Root 3 over root 6 is the square root of 1 over the square root of 2. Anytime you have the square root of 1, since we know that's simply 1, we don't have to put it. If we're left with a radical on bottom, this has to be cleaned up again by what we call rationalizing. We're going to multiply top and bottom by that square root. Remember that we cannot combine things that are not alike, so on top we are going to leave it as 2 root 2. On bottom we have 3 times the square root of 2 times the square root of 2 is the square root of 4, which we know is 2. So we can do one of two things. If you'd like to go ahead and multiply the bottoms, that's fine. Or we can now simply cancel. Since neither one of these numbers have a radical, we can clean it up in this way. We're left with root 2 over 3. We do have to be careful when there's plus or minus signs because that's going to force us to distribute what we're multiplying by or dividing by. So anytime we have this plus sign, this 3 root 2 is actually being multiplied by both of these, one at a time. So to multiply 3 root 2 times 4, again, we only combine the things we can. 3 times 4 is 12. We leave the root 2 alone. Plus, and then we've got to also multiply 3 root 2 times root 2, which is 3 times root 4, which we know that 3 times root 4, the root square root of 4 is just simply 2. So that leaves us with 12 root 2 plus 3 times 2, which is just 6. Second one, the exact same way. Anytime we have plus or minus signs, we have to distribute. So we're going to distribute 5 divided by root 2 plus root 3 is also being divided by root 2. We then are going to rationalize each of them by multiplying top and bottom by root 2 here. Remember that we can only combine things that are alike, so we're going to leave that as 5 root 2. Then on bottom, the square root of 2 times the square root of 2 is the square root of 4, or simply 2. Do the same thing on the second one. Multiply top and bottom by root 2. We can combine the tops here. So we got the square root of 6, all divided by the square root of 2 times the square root of 2 is simply 2 again.